And homework 2 is on arithmetic sequences and series. So the first handful of problems, the first page is all about the sequences, and then second page is about the series. So this first set, you're just determining whether or not the sequence is arithmetic. So the definition, remember, means that there is a constant difference from term to term. So if you look here from term to term, this one goes down by 9. This one definitely goes down by way more than 9. This one, it looks like there must be a constant multiplier, like they're being multiplied by 4 rather than adding anything. So this one is just a no, this is not arithmetic. If it was, you'd be able to just count over, identify the common difference, whether it's positive or negative, and then figure out the next 3 terms. Our next section, 7 through 10, write a rule for each sequence. So you guys had a little formula that we can use to figure out, and you need to know what the first term is. You also need to know the common difference. So the first term is super easy because it's always just handed directly to you. And then we can count out the common difference. So from 12 to 27, that's going up 15. This goes up 15 again, up 15 again. So you're really just subtracting term by term to figure out what the common difference between them is. So our formula looks like this. We have a sub n, so the nth term, you'd be able to plug in whatever you wanted into this formula, equals the common difference, d, times the quantity n minus 1, and then plus the first term, 12. So this basically just turns into like a distributing and simplifying sort of situation when you're doing these formulas. So you want to distribute the 15. So we would have 15n minus 15 and then plus 12. So this ends up being 15n minus 3. So you could plug in whatever value of n you wanted, and then that would tell you that particular term. So the rule for the sequence is this, and then we are looking to find the 18th term. So if you want a sub 18, you would do 15 times 18 minus 3. I need a calculator for that one. 15 times 18 minus 3 is 267. Okay, so that's why the formulas are so nice, because what we did yesterday, it was you could have just added 18 times, well really 14 more times. But that would take a while, so that's why the formula is a really nice thing. If you ever wanted to know the 200th term, it would save you a whole lot of time. All right, so the rest of these are just like that. Let's take a look at a couple on the next page. So we've got a rule for the sequence in this next set as well, 12 through 15. So you're kind of working your way backwards from the formula that we just used. So we have an a sub n. So remember, you've got your a sub n equals d times n minus 1 plus a1. Okay, so this time we know a value of n. So here we know the value of n is 5. So we can sub a5 in here, 5 in for n, we know a1, and then that will allow us to solve for d. We can kind of work our way backwards. So a sub n is a sub 5, so that is 27 that we are plugging in, equals d, that's what we want to solve for. N minus 1 is now 5 minus 1 plus a1, which is 11. So we set that up. It's pretty straightforward to solve for d, and then we can set up our equation. So 27 equals 4d plus 11. Subtract 11 from both sides. 27 minus 11 is 16. Divide both sides by 4. 16 divided by 4 is 4, and then that gives us our value of d. So once we have that, then you can sub that in to what this formula right here would be, just like we did on the previous set of problems. So let's do that again. So a sub n, now we're using a generic n, equals 4 times n minus 1, and then plus still the 11 here. That's still your a1. So distribute this 4. We have 4n minus 4 plus 11, and then this ends up, when we combine like terms, leaving us with this 4n plus 7. So this is the rule. We need that part first. And then it says use the rule to find a 9. So a 9, we would just replace the n with a 9. So this is 36 plus, I wrote a minus here. 36 plus 7 would give us 43. Okay, and the rest of those are very similar. We have one last category of problems here. This one, our sequence is 4 plus 6 plus 8 plus 10. You can see that's definitely arithmetic. You're just adding 2 each time. So you have a couple things that you need to figure out for this one. The indicated sum, you want to go up to 21. So the first part you need to figure out, because you've got this formula that we had in the notes, you need to know what a sub 21 is, right? So a sub n, we use the exact same formula that we just had up here. So d, the difference between each term is 2. And then n minus 1, we're writing 21 minus 1. And then plus a1, which is this first term right here, which is 4. So we just want to clean that up just so we know what a sub 21 is. So I probably should have actually written 21 right here instead of just an n. So this, start from the parentheses, 21 minus 1 is 20, times 2 is 40, plus 4 gives us 44. So that's the last term. So we have the first term and the last term, and remember that gets subbed into this formula. So the partial sum for 21 equals, and the formula works like this. It only works like this for our arithmetic series. So the number that goes on the outside is n, so we have 21, and then we have this quotient in parentheses, so we have the first term plus the last term divided by 2. All right, so it's like taking the average of the first and last term and then multiplying by how many terms there are, and that's going to get the sum, adding them all together. So 4 plus 44 is 48, divided by 2 is 24, so I have 21 times 24, which ends up giving me 504.